Hello and welcome to OSDR Chats. Today we have the opportunity to speak with Dr. Chris Mason from Weill Cornell Medicine. Using 3 datasets from the Open Science Data Repository, Dr. Mason and team's study of the blood-brain barrier indicate that even short-term spaceflight can disrupt human and mouse physiology. As they identify spaceflight biomarkers, this can guide countermeasure development. In this interview, Dr. Mason shares these highlights and implications with us and describes how the open science data systems and the analysis working groups contributed to this publication. Thanks for joining us today, Dr. Mason. Could you please highlight the most important finding in your study?
Thank you, and it's a pleasure to be here. And yes, we actually used a lot of modern genomics methods or omics methods that people use to look at many molecules at the same time. And in this case, we looked at the secretome, or what's present in the plasma of astronauts. In this case, the inspiration for crew members before and after spaceflight, and looked at see what was basically in the blood, in the plasma, and what proteins are present and what metabolites, say the proteomics and metabolomics we call it, to look at all of them that are present, in the blood, and then look at how that compares to essentially mouse data and any other previous astronaut data like the twin study. So we had a chance to look at these proteins, these metabolites that were changed, and see if any of them look like brain associated proteins, and some of them actually did. So what was interesting is we saw a little bit of evidence of this in the twin study, which we published a few years ago, but it was just one person, so we weren't sure how consistent it would be. But we saw, again, some of these same signatures of brain-associated proteins like alpha-synuclein showing up in the blood after spaceflight.
Cool, thanks. And my second question is, how do the open science data systems help assist you in your work so you can achieve these research goals?
The OSDR system was really pivotal because it helped us really organize and store our data, but then link to other mouse data. So for example, with Vivian Mao, we included some data from the RR-18, the Rodent Research Mission 18, that flew in space. And so of course, one of the questions was, if we're seeing brain-associated proteins, but does that mean there's a disruption in blood-brain barrier? Is it just different proteins being generated somewhere else in the body that are associated with the brain, but still being made somewhere else? As it just changes in fluid movements. So a lot of questions we had to look at other data, in particular look at rodent data, to see if there's evidence of, say, blood-brain barrier disruption, which we did see. There's a marker called PCAM1 that we saw increase in rats that had flown in space compared to ground controls. So it gave us additional evidence from the human data and the animal data that there seems to be a bit of change in the blood-brain barrier. And again, we don't think it's necessarily bad. It just means it's a little different. And what's exciting is it gives you a little bit of an indication of what's happening for some of the brain biology and cognitive function potentially based on what you can see in the blood. So it gives you a way to have a real biomarker of what's happening elsewhere in the body, but what you see in the blood. So the OSDR was a great, of course, repository linked to other data, and also now that's open for everyone to use.
Well, we appreciate hearing your insights from this research and your experience with OSDR, and thank you for sharing your time with our viewers.
Thank you very much.
And to our audience out there, you can learn more about this work, how to join the analysis working groups, and access the data set analyzed in this work with the links provided in the description section below. Thank you and have a great day.